Chapter 4, I'm so tired, even coffee can't get me wired. But this test we will review, it's Chapter 4, show what you can do. All right, practice, show what you can do for Chapter 4. It says number 4, but that was a mistake. Okay, so let's go through this guy here. The first one says, enter the scale factor from original to new. Scale factor is always going to be new divided by original. And I'll explain why in a second here. So, it does not matter which side you use as long as you're using corresponding sides. So meaning, if I use the 3 from my new shape, then the 6 from my original is going to be used. If I use the 4, then the 8 from my original is going to be used. And you can see that because if I go 3 to 6, that is equal to 4 to 8. And in both cases, it's equal to 1/2. So your scale factor is going to be 1/2. Now remember, scale factor, the other way I think about it is like, what do I multiply this number by to get to here? So I had originally 6, I multiply that by 1/2, and I get 3. Or I originally had 8, multiply by 1/2, and I get to 4. The other thing is, let's say, just as an example that I forget, and I think maybe it's original to new. And then I went, oh, 6 to 3, and I got 2 over 1, or 2. Think about this. Would I multiply 6 by 2 to get to 3? No. And this is going to make something larger. This is obviously getting smaller. So if my shape's getting smaller, my scale factor is less than 1. If my shape is getting larger, it's greater than 1. And if I multiply by a scale factor of 1, it stays the same. Okay, moving on to 2. Carmen is downloading music for her pod. Each song costs $1.85. Is this relationship proportional? Explain your reasoning. People were confused when you saw this on Friday because you could not identify the 2 variables here. So let's do that right now. In this case, we have an x and a y. My x is my number of songs. This each song part has it kind of hidden in there. So this is the number of songs, and the y is the price. Oof. Okay. So the first thing with a proportional reasoning is, or proportional relationship is it needs to start at 0, 0. So if I buy 0 songs, I pay $0. We're good so far. When I buy 1 song, it'll cost me $1.85. That's in the problem. 2 songs would be $2, $3.60, $3.70. This is going to make me nervous. I probably should use a calculator just so I don't mess up on the practice test video. That always looks bad. Here, and we'll do this here. So we had 1.85 plus 1.85 was 370. I'm going to add again for my 3rd song. So if I add another $1.85 song, it's going to be $5.55. And just for good measure, let's add the last one. So how do we know that this is proportional? Well, a lot of things. First of all, it starts at 0, 0. Has to do that. It grows by the same amount every time you go up for one of your x's. So we can think of it as every time this goes up by 1, this goes up by $1.85 every time. We can also look at the ratio of y to x. So remember, in a proportional relationship, k equals y over x. K is the constant of proportionality, or the unit rate, and it should be the same for all the points. And if you were to do this, if you were to go 1.85 over 1, that would be equal to 3.70 over 2, which is equal to 5.55 over 3, which is equal to 7.4 over 4. They're all equal, so this is proportional. And the cost for 5 songs, actually I'll use another way to do this. We can multiply, if I multiply the x by 5 to get to 5, then I would multiply $1.85 by 5 to get that price. So it'd be 5 times $1.85. Again, I'm going to use my calculator just because I don't want to make a mistake. 1.85, 9.25. Very, very cool. All right. Moving on to number 3. All right. What is the constant of proportionality in the graph given below? I want to talk about 2 things here. I want to talk about this problem, and then I want to talk about if I may give you a slightly tougher problem on the test. First of all, constant of proportionality is another word for unit rate. The word unit means the number 1. So we're looking at how much y do I get, in this case points, for every 1 x, in this case games. I could find it right here when x is 1. So when x is 1, what's my y value? It's 20. Oops. Now, what if I gave you a graph where you could not see that point, where let's say it was in between 2 points? I'm going to use the same example just to show you what you can do. If you can find any point on the graph, like this right here, if I know that 4 goes with 80, so I know that the point 4, 80 is in my proportional relationship. Well, remember what I said last problem. K, the unit rate, is always y over x, because we know it's already proportional in this case. So I can take 80 and divide it by 4, and sure enough, that's that 20 for my unit rate, which we already knew, but I'm just showing you again, just in case I didn't give you that. I feel like I'm rolling through this pretty quick. All right, so second part here of 3. Billy earns money by walking dogs. The table represents the proportional relationship between the number of days Billy worked and the amount he earned. Identify the constant of proportionality. Again, okay, so this one, again, they give you the point. We gave you 1. So if we give you 1, your unit rate's right here. It's 650. Oops. I'm really struggling here to write these right. Sorry about that. But what if I didn't give you 1? It doesn't matter. As long as I know it's proportional, I can just divide y by x. So I could go k equals y over x. So that's 19.5 or 1950 divided by 3. And sure enough, if you divide that, just in case you don't believe me, 19.5 divided by 3, 6.5 or 6.50. So a couple different ways to do that there. I might not give you the 1 on the actual test. Same with this. I might not give you the 1 on the graph. All right. This table shows a proportional relationship between x and y. Find the constant of proportionality. Notice that's a really common thing here. We're going to have to find the unit rate. You have to be able to find the unit rate. This is one where I did not give you the 1. So, does it matter which one I use? Does it matter if I use this y and x, or this y and x, or this one, or this one? No, because it's already proportional. So if we know it's proportional, we know they should all be equal. So I would not do, when I go to do k equals y over x, I would not choose 9.5 over 3. You can, it's fine. But 9.5 is ugly to divide by 3. 9 and 6, way easier for me to deal with. 9 over 6. Oh, that was exciting. I just spilled some espresso. There's the aftermath. Oh, all right. All right, well, we're going to pause this video. All right, hold on. All right, I'm back. I'm not sure if this is irony, but I think it might be. The irony there is that I made my espresso to prevent me from being too sleepy, and then my really intense sleepiness is why I spilled the coffee all over the paper. But we're back. So we're going to do y over x, and I was about to do 9 over 6, which I can divide by a giant 1 of 3 over 3 to get 3 over 2. And that's my unit rate there, 3 over 2. So for my equation, k is my unit rate, my constant of proportionality, and you just leave the y and the x. So it's going to be y equals 3 over 2x. That's it. And what we're saying here is if you plug in our x, like if I plug in 6, 6 times 3 over 2 will give me 9. Or 12 times 3 over 2 will give me 18. I'm going to show you just to show you. So, for example, y equals 3 over 2 times, let's go ahead and use 12. 12 divided, I'll do 12 times 3. 12 times 3 would be 36. 36 divided by 2 is 18, which is what I thought it was going to be. All right, and on to 5. We're almost there. Pretty short one here. Look out just in case there might be a couple extra questions. We'll see. I will let you know if there's going to be more. Okay, we're going to combine like terms. So I like to, there's a lot of different ways you can do this. I like to kind of rewrite all my subtraction as addition and then move them around. I think that's a convenient way to do this. So I would maybe rewrite this as x plus -3 plus 5 and then plus -2x. Because now I can rearrange everything and I can write this as x plus -2x plus -3 and plus 5. X plus -2x gives me -x. -3 plus 5 gives me 2. On to B. Similar idea. I'm going to do this one without rewriting it though. As long as I bring the sign in front of the number with me, I'm okay. So I'm going to write this as 2x minus 4x. And then I'm going to put this -3 right here. And then plus -1. I know some students get confused because you go, wait, that's a -3 and this is a -3. But remember, it's the same thing. Adding a -3 is the same as subtracting a +3. So I can do that. I can move it as long as I bring the sign in front of the number with me. 2x minus 4x gives me -2x. And -3 plus -1 gives me -4. Or if you wanted to, you could write it as plus -4. It's up to you. Both are cool. C is the distributive property. Remember, we distribute the 8 to both. So that would give me 8x minus 8 times 4, which I totally know and I'm not stalling for. Okay, is 32. So 8x minus 32. That's it for that one. We can't do anything else. And the same with D. That would be 6x minus 60. I think that's the whole thing. That's it. Thank you guys for watching. Please let me know if you have any questions. And good luck on your test on Thursday. That's me. I'm very tired. Oh, but I'm not sad though. I'm happy. I'm happy about being tired. It's good to be tired. Have a good day.